let's jump right into this explainer, because today we're tackling a universal frustration. We're building these absolutely incredible AI tools right now, but they have this massive, quiet flaw that drives us all crazy.
I mean, you know exactly what I'm talking about, right? You upload a PDF, you ask a great question, and boom, you get a brilliant answer. But then the conversation ends. You close the chat and poof, everything just evaporates. The very next day, you ask a simple follow-up question, and the AI acts like it's meeting that document for the absolute first time. Because, well, it is.
And this happens because the AI literally has zero memory between sessions. It doesn't retain a thing. Think about all your research papers, your meeting notes, those half-finished projects. You've built up all this knowledge, but your AI? It acts exactly like a librarian who wakes up, reads every single book fresh each morning, and has absolutely no notes from yesterday. Every single query starts totally from scratch.
So to patch this amnesia, the industry came up with a standard workaround over the last couple of years. It's called RAG, which stands for Retrieval Augmented Generation. Now, the process is pretty technical. Basically, you take your documents and chop them up into thousands of tiny chunks. Then, you convert those chunks into these massive lists of numbers called embeddings. Store them all in a specialized vector database. And finally, at query time, the AI just grabs the chunks that seem closest to your question.
But that right there perfectly illustrates the flaw. Look, RAG works really well for simple lookups, for sure, but it is completely stateless. The knowledge never actually accumulates between your sessions because the whole system was designed for retrieval, not retention. Compare that to human memory, right? Our memory compounds over time. A human expert gets smarter, building deep connections with every new fact they learn. RAG, it just hands the AI a fresh pile of disconnected snippets every single time.
Okay, so then, in April 2026, the whole landscape shifted. Andrej Karpathy, you probably know him, co-founder of OpenAI, former head of AI at Tesla. He quietly published this concept online that flipped the entire RAG pipeline completely on its head. He proposed this brilliant idea that he called the LLM Wiki. He essentially realized we had the whole process totally backwards. His core insight is incredibly profound. Stop asking your AI to find knowledge and start asking it to build knowledge. Instead of having the model blindly search a database and scramble to rederive connections the exact moment you ask a question, we should just build that knowledge up front. We turn it into a living encyclopedia.
And the crucial point here is this massive technical contrast between the two. Think about it. To build a RAG system, you need embeddings, orchestration frameworks, complex APIs, and those really expensive vector databases. It's exhausting just thinking about it. But for an LLM wiki, you literally just need a local folder of plain text Markdown files and get. That's it. It lives exactly like code. No database, no server, and absolutely no API key needed just to read your own files. This shocking simplicity is exactly why Google actually stepped in. Google Cloud took this loose community idea and published it as a formal specification. They called it the Open Knowledge Format, or OKF, and they proved that yes, a simple folder can absolutely scale to the enterprise level. It's an enterprise standard where the defining feature is actually how incredibly little it demands from you.
So how do we actually build this OKF bundle? Well, it's structurally super simple. It relies on just 3 distinct layers. First up, you have the raw folder. Think of this as your inbox. You just dump your messy, unorganized PDFs, articles, and meeting notes in there and walk away. Second, there's the wiki folder. This is where the magic happens, where the AI actually writes structured pages based on your raw files. And finally, the schema file. You'll often see this called Claude.md or schema.md. This is basically the brain's rulebook. It tells the agent exactly how to write, what tone to use, and exactly how to structure every single page. Now, when it comes to the files inside that wiki folder, every single file represents one concept. And there's exactly one hard rule here. The file absolutely needs YAML front matter at the very top. Think of this front matter like a tiny index card. It tells the AI the concept type, the title, and the tags, all without making the AI read the whole text. Then, right below that, you have your standard Markdown body. That's just free-form text where your actual wisdom, your tables, your code, and your data live.
But we have to remember the massive paradigm shift here. You do not manually write this wiki yourself. Your AI agent acts as this tireless, genius librarian. You just supply the raw material and the AI workflow kicks into gear. It actively reads all your messy notes, writes the beautiful structured Wikipedia-style pages, and crucially, it uses wiki links to weave related concepts together. So by the time you actually ask a question, the hard work of cross-document synthesis has already been done for you.
Now, you might be wondering, what happens when things change? I mean, if nobody tends to the folder, the knowledge is going to rot, right?
Well, to solve this, the agent runs what Karpathy calls a lint function. Basically, the agent periodically sweeps through the entire folder system. It actively hunts down expired information, and when you drop in new data, it actually flags contradictions between the new stuff and your old claims. It triggers updates completely on its own to ensure your AI's brain is always highly accurate. It becomes this living, breathing synthesis of your expertise.
Okay, but how does this scale? You're probably thinking, what happens when a massive enterprise company has, say, 9,000 files? Won't that completely choke the AI's context window if it has to scan a folder that big every time?
Well, this is exactly where the magic of the OKF structure truly shines. Because the agent has already actively maintained the structure and written those handy YAML index cards up front, the model doesn't have to read everything. It only needs to glance at a short table of contents. It pinpoints the exact file it needs and effortlessly skips the other 9,000 documents. It never chokes on the whole library because it simply doesn't have to.
This represents such a massive shift away from relying on clunky, complex infrastructure. As our sources beautifully point out, the complexity lives in the AI, the knowledge lives with you. The heavy lifting of connecting concepts and writing all those summaries, that's done by the AI up front. But you retain total, offline control over your plain text knowledge. It is 100% yours. It lives locally on your machine, not locked away in some proprietary cloud database.
So as we wrap up this explainer today, I really want to leave you with a provocative thought. We are rapidly moving toward a world of personal, persistent AI that just grows quietly in the background for us. So if you could build a compounding, brilliant AI brain, starting with just one single text file today, what knowledge would you put in it?